Hi everybody, welcome to our live remote training. This is Aaron Callahan from ArcLight Dynamics. I'm here to show you the ins and outs of using an Arc Pro CNC plasma system. Today we're going to talk about setup, we're going to talk about maintenance, we're going to talk about air and power as well as water. We're going to talk about maintaining your system, operating your system, and we're also going to give you some tips and tricks on how to use your system most effectively. We're going to start our training today with the basic setup of the table and maintenance of the table, and then we'll get into the software later on. We're going to break this up into two sessions. We're going to do about a 90-minute session initially, and then we're going to have maybe a 15-minute break or so, and then we're going to finish up with another 90-minute session. Like I said, we're going to start off with maintenance of the table and setup of the table initially. So when it comes to receiving your ArcLight Dynamics Arc Pro CNC system, such as this one right here, you're going to receive your CNC system with the control cabinet strapped to the top of the table. So you'll need to mount your control cabinet spine, mount the control cabinet on the mounting bracket, and then begin connecting your wires. You're going to have a wire loom on the side of the table that you're going to be connecting in through the bottom of the control cabinet. This is going to include several connections. Brian, if you'll grab the camera and come on up, let's show them some of the connections we have to make here in the control cabinet. In the front of your control cabinet here, you'll have this block of wires from your switches. These switch wires will be routed in from the bottom of the control cabinet and up into this plug right here. This will already be attached. This is your e-stop wiring right here. This will already be attached, so you only have one spot to plug these wires into. That'll go into that bottom socket right there in your motor controller. Once you've got your switch wires connected, you're going to want to make a couple other connections. For those, we're going to go around the back. So this is the wire loom coming from your table going up into your control cabinet. Our wire loom has some connections here so that we can connect other types of systems to this table. Yours will be solid wiring all the way up through here. These wires are labeled A, Z, Y, and X, and they connect to the back of the motor controller right here. We have these connections with these plugs that are terminated with screw terminals to make sure that they're secure. It's very important that you not connect any of these motor wires or disconnect any of these motor wires while the motor controller power is on. Make sure everything is turned off if you're going to be connecting or disconnecting any of these motor wires. The additional connections that we have in the back here include two power connections. One power connection is for your motor controller. The other power connection is for the auxiliary outlets that you see here. These auxiliary outlets are typically used for the router package or our engraver package that we have installed on this system. So once you run your wires up into the bottom of the control cabinet, you're going to make your switch connections and your motor control connections. You'll also have a couple of Ethernet cables that you'll be pulling out of the control cabinet and running to the other side. The Ethernet connections that you see here are going to be labeled to PWM sensor and for the Arc Sync technology. These connections are going to run over to our plasma cutter. Let's take a walk over there. So we have our plasma cutter set up on the other side of the CNC system right here. I've got this plasma cutter tucked under the table to protect it from splashing water. Now if I pull the plasma cutter back here, you can see those two Ethernet connections that we looked at on the other side. You're going to pull those Ethernet connections from the bottom of the control cabinet. You're going to connect the one marked to PWM sensor to this sensor box right here. This is a very important sensor box. This connection to this PWM sensor controls the torch switch, turns the torch on and off. It also controls the arc OK signal. So once you've established an arc to the material, it tells the system, yeah, we've got an arc established, we've got a complete circuit, it's okay to start moving. Additionally, this also controls your torch voltage feedback. That torch voltage feedback is what makes your digital torch height control work properly. Communicates that torch voltage from the plasma cutter through the PWM sensor back to the computer system. The additional Ethernet cable that we have here, this white Cat5 cable, is for the Arc Sync technology, what we call HYT SIM kit originally. This Ethernet connection plugs into this special adapter right here, which goes into the serial interface module on the back of your Hypertherm. This serial interface module, HYT SIM kit, Arc Sync technology, is for automated amperage control. This automated amperage control is going to set the amperage on the plasma cutter for you automatically. This is really helpful for your students. It's one less step to remember. It's one less thing to possibly mess up. So having that ArcSync technology equipped is going to set the amperage automatically. It's also going to give you a soft pierce feature. This soft pierce feature reduces the wear on your consumables, extends your consumable life, and saves you money. Additionally, the ArcSync technology also communicates any errors from your plasma cutter. If you were to have an error on your plasma cutter, such as a loose retaining cap, you're going to see this warning light pop up right here and an 050 code. That 050 code you would then have to look up in your operator's manual to figure out what it means. Of course, we know it's a loose retaining cap because I just untwisted the retaining cap here. But when you have an error like this with the ArcSync technology, it's actually going to display the information on the computer screen, and it's going to tell you retaining cap loose, or it's going to tell you that your torch consumables are stuck, or it's going to tell you that you've got no air pressure because somebody forgot to turn on the compressor that morning. So with the ArcSync technology, what we called HYT SimKit initially, these error messages are going to be communicated on the computer screen, not just as a code on the front of the plasma cutter. Makes it a lot easier to troubleshoot problems and fix what's wrong and get back to cutting. So while we're down here with the plasma cutter, let me show you a couple other things here. Now, we talked about your serial interface module back here. This is where your HYT SimKit ArcSync technology connects. We've got the Pico 1 cable from our PWM sensor, this gray wire right here that comes from the PWM to the CPC port in the back of your Hypertherm plasma cutter. This is our air inlet. We've got this teed off so we can connect it to our engraver package when we want to. And we've also got our power switch right back here. When you want to cycle your plasma cutter off and on again, such as to clear an 050 code like we just caused by loosening the retaining cap, we're going to cycle our plasma cutter off and then back on. You've got two resets for your plasma cutter. A soft reset, such as the one that I just did. You wait about 5 seconds and turn it back on. If you wait for a full minute, it discharges the electronics inside, and that's a hard reset for your Hypertherm plasma cutter. All right, so that's it for the back of the Hypertherm. Let's talk a little bit more about the front of the Hypertherm right here. Here in the front of the Hypertherm, we've got our amperage display. This is also where we're going to display any error codes. This knob right here is the amperage control. You can see we can turn the amperage down to 45 amps for if we're cutting fine cut, for instance. We can turn it up to 65 amps if we need to cut at max capacity for this PowerMax 65 plasma cutter. We've got our mode selections over here. Top mode is for perforated or expanded steel. Second mode is primarily what you're going to use, that's solid steel cutting. Third mode here is for gouging. We rarely use that on the CNC system. And then we've got a hand torch lockout, which we don't use on the mechanized system. We almost always have this set on our second setting, unless we're cutting perforated steel, in which case we use the top setting. We've got some other connections here. I definitely recommend that you check out your Hypertherm operator's manual for information on adjusting air pressure manually. Typically, we let the Hypertherm take care of air pressure adjustment. Additionally, if you have the HYT SimKit, the ArcSync technology, then you also have the ability to automatically set your air pressure from the G-code that the computer's running. So it'll automatically set amperage as well as air pressure. It communicates error messages, and it saves you money on your consumables. A lot of great reasons to invest in that ArcSync technology from ArcLight Dynamics. All right, so that's the ins and outs of our plasma cutter. We've got a couple other things to talk about here. When it comes to connecting your plasma cutter, we've got this plugged into a 50 amp outlet back here. That 50 amp outlet is running into a NEMA box and into the back of the plasma cutter. That plasma cutter has the torch lead coming out the front, as well as our work lead coming out the front. Now the torch lead and the work lead, they can play together. That's not that big of a deal. The torch lead, you want to make sure that this guy does not get any kinks in it. There are air lines in here, and if those air hoses get kinked, it can cause damage that would cause you to have to replace your torch lead. Your work lead and your torch lead can run out of the front of the plasma cutter and work their way around the table. As you can see, the torch lead is going to make its way from the floor up into the cable chain right here. If you have a wall next to your CNC system, you might consider mounting your plasma cutter on the wall and running the torch lead in there. Your work lead is right down here. Notice this work lead is kind of set up like a snake right here. This work lead is not coiled up. It's not crossing over itself, and it's as far away as possible from our 220 volt power line. This work lead right here is going to carry your torch voltage feedback information for your digital torch height control. And if this work lead is running right next to a 220 volt power line, it's going to cause an inductive voltage in the work lead, which is going to cause incorrect voltage feedback, and your torch height control could act up. This is a great physics lesson for your students. Some of the theory behind this is that if you've got a 220 volt power line and you've got a ground cable running right next to each other, you're going to have an electromagnetic field spiraling around that 220 volt power line. If your work lead's laying right next to it, it's going to induce voltage into that work lead, and that's going to cause incorrect voltage feedback. This work lead is not coiled up, it's not crossing over itself, and it's running all the way to the back of the CNC system here, where we've got it clamped. If you want to come around there, and you can see the clamp attached to the ground tab in the back. In addition to the ground tab that you have in the back of the table, you've also got a ground tab here in the front of the table as well. We've got some new recommendations for grounding your CNC system. We're developing a ground bus bar. This is going to be available for retrofit to previous generation systems. That ground bus bar is going to allow you to ground your CNC system and preferably connect it to an earth ground as well. If you have that available, a lot of customers like to connect one ground tab to their work lead, the other ground tab to their ground rod. Many customers prefer to shorten their work lead. As you can see, the work lead here is very, very long. If you are dedicating your CNC system with a plasma cutter and you're never going to take that plasma cutter off of the CNC system, I strongly recommend cutting your work lead in half. Cut that thing in half, put a ring terminal on it, seal it with some silicone, and then bolt that to your ground tab. These ground tabs do have bolts, so you can run a bolt through it and bolt your ground tab straight to there. Then you can use the other half of your work lead with your clamp to attach that to your ground rod. So we've got a lot of different options as far as grounding goes, and shortening your work lead is a great idea, but do remember to seal the cable if you shorten it and put a ring terminal on it, because if water gets up into that cable, it can be whipped through your entire work lead, corroding the work lead due to capillary action. So it's very important to keep that work lead out of the water. Let's take a look at the water in the water pan right here. We've got our water filled up just about to the top of the slat supports. This water is going to eat up a lot of the dust and smoke that's created from plasma cutting. The water is a solution of anti-corrosive agent. We use a product called Pico Quench Guard. Pico Quench Guard is typically used in about a 2% solution. So in a 4x8 table, you're going to use about 2 gallons. As the water begins to evaporate out of your table, you will have the need to add more water. If you see rust starting to form, add a little bit more of that Pico Quench Guard plasma cutting solution in there as well. The water in the water pan is non-toxic, biodegradable with that solution in it. That water can be drained out of your water pan via the 1-inch ball valve that you have in the back there. That 1-inch ball valve allows you to drain the water out so you can do your clean out. Perhaps at the end of the school year, you're going to drain the water out and have the students pull the slats. Now, of course, these slats are extremely sharp. We don't have a lot of rules here at ArcLight Dynamics, but one of the rules we do have is you must wear gloves when handling slats. So once you've got your water drained out, you're going to go ahead and pull these slats out. You're then going to use the transfer shovel to scoop all your slag out, toss that in your steel bin, and then you can repopulate your table with slats. You can rotate these slats. You'll see the slats in the front generally get cut up more than the slats in the back. You can flip these slats over and then use the bottom side of it for a clean cutting surface. Once you have repopulated your slats, you can put your water back in and put your anti-corrosive solution in there as well. All right, so let's see here. That's about it for water. Let's talk a little bit about air. So we've got our air inlet coming in from the compressor. That air inlet is coming into our 5-stage air filtration unit right over here. This 5-stage air filtration unit consists of a water trap. The water trap here is going to allow us to drain any water that's collected in the trap out. We've got our MotorGuard M30 paper filter. This is a submicronic particulate filter that's going to trap any dust that's in the air, any particulate matter, contaminants. You don't want them getting through to your plasma cutter. Then we've got an oil vapor coalescing chamber. This is going to coalesce oil vapor out of your compressed air. It's going to trap that oil vapor in there. We've got a desiccant dryer here as well. This desiccant dryer comes with silicon desiccant beads. These desiccant beads start out cobalt blue. Those cobalt blue beads turn pink once they've started soaking up water. This is going to soak up the water and dry your air out. Your 5-stage air filtration unit comes with an additional bag of desiccant beads. So once these go pink, you'll be able to pull these out and put your fresh beads in. You can then take your pink beads and take them down to the home ec kitchen and toss them in the oven for about 30 minutes at 300 degrees. That's going to turn these beads back to cobalt blue.
Tim Tucker said, can we rewind a bit?
Okay, sure. Back to air or back to water?
Let's see here. Water.
Okay, sure. So we're looking at our water pan here. This water pan includes our ground tabs, front and rear. And it's very important to keep these ground tabs from getting rusty. These ground tabs are where you connect your work lead to, and also where you connect your earth ground to. The water pan is meant to be filled with water and anti-corrosive agent. We primarily use Pico Quench guard, although we've been known to use a couple of other different kinds of anti-corrosive agents. We're typically using this in a 2% solution. So if you've got a 4x8 table, holds about 100 gallons, you're going to be using about 2 gallons of anti-corrosive agent. When filling up your water pan, you're going to put the anti-corrosive agent in, and then you're going to fill it up with the hose. The anti-corrosive agent is non-toxic and biodegradable and can be drained via the 1-inch ball valve in the back of the table. If you see rust starting to form in your water pan, you'll need to add a little bit more anti-corrosive agent. We typically sell it in 5-gallon buckets, so we'll use 2 gallons on our initial fill, and then the water will evaporate, and then you'll add a little bit more anti-corrosive agent to keep the rust at bay. With a school situation, you guys are probably going to be filling up your water pan, filling it with anti-corrosive agent at the beginning of the semester, and at the end of the semester, when you're done with all your cutting, you'll be draining your water out, pulling your slats out, and then scooping all your slag out and throwing it in your recycle bin. You'll then be able to repopulate your slats into your table. You could rotate them, you could flip them around, and use the bottom side for a clean cutting edge. I imagine you'll be doing that at the end of each semester. This water pan is galvanized. It's about 3 inches deep. We typically run our water level up to the top of the slat supports. Can you come in and get a shot of the slat supports here? So you can see where the water level is at with the top of the slat support here. Good rule of thumb is that with thinner material, you're going to want to run your water level up a little bit higher. With materials such as aluminum, you'll actually want to run your water level a little bit lower. It's important that you ventilate any gases created by cutting aluminum. If gases from aluminum cutting get trapped and get pocketed up, those pockets can then ignite and cause small explosions. It's not going to be a fatal explosion or anything like that, but it'll be a little pop, pop, pop. That'll move your aluminum plate around, and that gets expensive because it messes up your cuts. So it's a good idea to open up the bay door or set a box fan next to your table when cutting aluminum to help ventilate those gases. Any questions about the water pan, water levels, anti-corrosive agent?
No questions.
All right, good deal. I kind of went through setup a little bit more quickly than normally because I figured you guys have had the tables for a little while and have had a chance to at least get them set up in the shop and get them leveled. Is there any specific information anybody needs about leveling their table or about making any of the wiring connections?
I have no comments.
Okay. All right, we're going to go back to the air filtration unit. As we were discussing, the air quality is extremely important to good plasma cutting. You need clean, dry air.
Tim Tucker says yes. Can we go over the initial setup leveling?
Okay, sure. So let's take a look at the front of the table here. All right, so when we're first setting up our ArcLight Dynamics Pro CNC system, we're going to get our frame and we're going to position it in the right place. You can see the frame is equipped with heavy-duty caster wheels. These caster wheels here come equipped on every table, and once you get the table into place, you're going to jack it up with an automotive floor jack. You're going to use your automotive floor jack right on the front end bar of this table. You're going to jack the table up, then you're going to use the 1/2-inch wrench to loosen up these bolts, and then you're going to slide this wheel up into place. Once you get those wheels slid up into place, then you can lower the table back down onto its feet. I like to put a little bit of water in my water pan, just a little bit of water in there just to help me level it out. You'll see that there are flat bar sections in here that hold the slat supports in place. So I just add enough water just to cover those sections of flat bar. And I'll use my leveling feet. These grade 8 bolts here, these are your leveling feet. So these carriage bolts can be twisted out and they have a lock nut on them that's going to allow you to level your feet. So once you have your 4 feet leveled and you see that by the water in the pan, use that water to help you eyeball level, then you can lock those 4 feet into place and you've got your table leveled out. After you've got your table leveled out, you're going to want to bring your bottom middle legs down. So Brian, if you'll come in here close, pull this out of the way. You can see the center leg right here. This center leg has its own foot with lock nut on it. Now my lock nut's not locked. There we go, that's a little better. So once you've got your table leveled, you then bring your center foot all the way down in the middle. That center foot then should have a little bit of positive pressure. Once you hit the concrete, give it another 1/2 turn or so. Just a little bit of extra pressure in the middle to help keep the table from sagging in the middle. This is particularly important with 4x8 and 5x10 size tables. Just a little extra positive pressure for that leg in the middle will help keep it from bowing once you get 100 gallons of water in there and you put 200 pounds of steel on there. All right, so of course, if you need to move your table, once you've got it set in that spot, you do have to drain the water out of it, because as soon as you jack one end up with a floor jack, all that water dumps out the back end. Ask me how I know. The table is, once it's leveled and set in place, you take that center leg down just to give it a little bit of extra positive pressure. Don't give it too much pressure in the middle. You don't want it to curve up or anything like that. Just an extra 1/2 turn on that bottom foot should get you in the right spot. All right, so that was our setup and leveling. We have our connections in our control cabinet all made. We've got our plasma cutter all set up. We talked about the solution of the anti-corrosive agent we're using in the water pan and what the procedure is like when you clean that out for the first time. We're going to go ahead and go back to our air filtration unit as we were discussing the desiccant drying and the regulation of the air pressure. Follow me back this way. So the 5th stage that we added to our air filtration unit is this regulator right here. We found this very important because if you give too little air pressure to your hypertherm plasma cutter, you're going to experience pop-outs and errors. If you feed too much air pressure to your hypertherm, you could do damage. The max PSI input is 135. So we regulate this to 120 PSI right here. That results in no pressure drops below 90 PSI, and of course it doesn't exceed the maximum inlet pressure of 135 PSI. So it protects your plasma cutter and helps keep it from having pop-outs and other errors. It allows you to maintain the proper air flow and pressure to achieve proper plasma density and burn through your steel. This air filtration unit is connected to the back of the plasma cutter on the other side, which we showed you earlier. All right, so we talked about water, we talked about air, we talked a little bit about power as well, as far as the ground cable and some of the theory behind torch height control. Let's talk about that a little bit more. We talked about the torch feedback voltage. Once the torch strikes an arc to the material, we need to measure the gap, the torch to work distance. That torch to work distance is expressed in voltage. It's very similar to the stick out on a welder. The more stick out you've got on your welder, the more wire you've got stuck out there, the bigger the gap is between your electrode and your workpiece. That means more air that you got to force that electricity through. You need to have higher voltage to get that current, that arc, to go through that much resistance. So when it comes to torch height control, this theory is very, very similar. If we're cutting through 1/4-inch thick material at 65 amps, we need to maintain a certain speed and a certain height. Now that height is going to be determined by the torch voltage feedback. So the system is going to measure the voltage across the arc. And if that material starts to warp as we're cutting it and bend up towards the torch, that torch to work distance is going to shorten. Therefore the arc is going to shorten. Therefore the voltage is going to decrease because everything else is staying constant. When that voltage decreases, say the system thinks it's supposed to be at 130 volts at the proper height, proper speed, proper amperage, proper thickness of material. Well, it says, hey, I'm not at 130, I'm at 129, 128, 127, indicating that the material is starting to warp. The machine will then pick the torch up. It will begin to raise the torch until we achieve the 130 volts that we're supposed to have. So as the voltage starts to drop, the system will raise the torch until the voltage equalizes its preset volts once again. This torch height control theory is very important to understand because that will help you troubleshoot problems. For instance, if your consumables are worn out, you'll start to see wacky torch voltage. If you have a lot of water or contaminants coming through your airline into your nozzle, you're going to see incorrect torch voltage feedback. If your work lead is too close to your 220 volt line, you're going to have incorrect torch voltage feedback. That could cause your torch to ride too low, ride too high, rise, or dip. So the torch height control circuit is a very important circuit to understand how that works. Hit me up if you have any questions. I know this is a little bit more detailed information, but I want to make sure your teachers are equipped with this kind of information so you can impart that knowledge to your students. In the meantime, we're going to talk about some maintenance on the CNC system. A couple of things that I keep on hand all the time. A rag is one of them. WD-40 is the other. And a Scotch-Brite pad. If there's only one thing that you do to maintain your Arc Pro CNC system, it's going to be clean your rails. These rails should be wiped down pretty much after every sheet. And primarily what we're concerned about is the surface that the bearings ride on right here. We want to keep these rails clean so that our bearings have a nice smooth surface on which to ride. Now we're not going to use anything terribly abrasive on here, and we're not going to use any grease or anything like that. After I cut a sheet of steel, it's going to spit a bunch of water up on these rails, and that water is going to have plasma dust in it. So I'm going to dry them off by running a rag down there. You know, once I pull my skeleton off, pull all my parts out, then I'm going to run the rag down the rails, then I'm going to load a new sheet on. And when it comes to the end of the week, I'm going to hit them with some Scotch-Brite and WD-40. At the end of the week, I want to make sure I clean any gunk off of this and put down a protective coating on it. Now, I don't want to use anything too thick, like grease or anything like that. Just something nice and light, like WD-40.
We do have a quick question. What do we want to do with the water table to prevent it from freezing overnight?
If your shop is unheated, you've got a couple of different options for the water pan. My favorite option is to use an automotive block heater. I use a magnetic block heater, the same one I use for my 58 Apache. I use on my CNC system. They're only about 30 or 40 bucks from most auto parts suppliers, or you can get them online. It magnetizes to the bottom of the pan and keeps it from freezing, so that works out really well. There are also thermal additives. You could get Pico thermal from Pico Chemicals, same people that make the anti-corrosive agent. That Pico thermal can be used in solution to lower the freezing point of the water in the pan. That's an option as well. Some people will circulate their water in order to keep it freezing, so you could try that too. Even the small space heater is perfectly fine. So back to cleaning our rails. The rails that we have here are the cold rolled steel rails on the side of the Arc Pro CNC system. I'm going to hit these with some WD-40. I like to use the liquid spray WD-40, and then I'm going to use my Scotch-Brite pad and scrub these rails down. I'm going to make sure that I'm concentrating not just on the top of the rail, but also on the side rail and underneath the rail as well. These are 6-point bearing blocks. We've got 2 bearings on the top, 2 on the side, and 2 underneath. So I'm going to make sure when I'm scrubbing this with my Scotch-Brite that I'm hitting all 3 of those bearing ride edges at the same time. So I'm going to do this weekly, although your maintenance schedule could vary depending on how much you're using your table. All right, now that rail's all clean and happy. So, the Arc Pro CNC system has the cold rolled steel rails on the sides. On your gantry, you've got precision linear rails. These precision linear rails are equipped with slide blocks rather than 6-point bearing carriages. These slide blocks are around this side. So our slide blocks are here and up here. Now we've got a couple of grease fittings. This is a Zerk fitting right here that you can see. And then we've got a Zerk fitting tucked in up here as well. All right, you can get regular grease guns on there for the most part. You'll want to put a couple of pumps of grease into those slide blocks weekly. That's 2 pumps of grease into each of those big slide blocks every week. In addition to the 2 slide blocks that we have on the X-axis linear rails here on the gantry, we've also got a couple of slide blocks here on the Z-axis. This Z-axis, even though it's a very small rail, it's a very important rail. We've got a slide block facing up here with a mini Zerk there, and then there's another slide block here with a mini Zerk on the bottom. See that mini Zerk right there? So getting to those mini Zerks can be tricky. One of our customers came up with a really, really nice way to get them, and that is with this Oregon bar oiler. This is for certain chainsaws that have grease fittings at the end of the bar, right? This works out really well for these little fittings right here. It's hard to get a standard grease gun onto this little mini Zerk. So what you can do with this is put it right into the middle of that mini Zerk fitting and pump grease in with it. It's a little bit trickier to get it from underneath, but it is doable. There it is. Not bad. All greased up for nice smooth action. It's really important to have good smooth action on this Z-axis slide because this goes up and down with every single pierce. Every time your torch touches off the steel, it's going to slide up on this slide. If this is gummy, If this sticks, if this hangs up and doesn't allow the torch to come back down under its own weight, it's not going to close this switch back here properly. These wires right here are going to the Z-axis switch. I'm going to come up here. That Z-axis switch is located right there. That Z-axis switch down there is what is opening and closing to tell the system that it is touched off the top of the steel. So if that slide hangs up like that and doesn't drop back down and close the switch, it's going to cause errors. It's going to cause touch-off errors, and that's going to stop you in your tracks. So it's really important that you maintain the lubrication on the Z-axis slide blocks. Don't forget about the one on the bottom. It's out of sight, out of mind. Make sure you always hit 2 grease fittings, 2 on the X-axis, 2 on the Z-axis. Keep your rails scrubbed, and that should keep your system in good condition. All right, let's see what else we have here for maintenance. We've got several scheduled maintenance directions in your operations manual. Take a look at the operations manual. I believe I sent you guys the link to be able to download the operations manual. Tim, you guys got those there? You guys got the electronic versions, or did you print copies out there?
No response.
Alrighty. So this is our operations manual. This is the Comprehensive Arclight Dynamics Operations Manual. If you guys didn't get these with your earlier model systems, we do have these available. I can send you the link so you can download them. This includes the scheduled maintenance. Talking about daily maintenance, we talked about wiping down the Y-axis rails with Scotch-Brite and some WD-40. Weekly maintenance, we talked about greasing your fittings, such as the fittings on the gantry as well as the fittings on your Z-axis. Make sure you reference this maintenance schedule. It is broken down daily, weekly, monthly, quarterly, biannually, and annually as well. So it's really important to look over this and follow the instructions that you have here to keep your system operating optimally.
Mm-hmm.
We've got a couple other things that we need to check and lubricate on the system here. In addition to the grease fittings that we have for the Z-axis slide and the X-axis bearings, there's also a threaded rod in here. There's a threaded rod with a motor and some bearings inside the Z-axis. Now, I don't have the ability to show you this at this point, but let me see if I can pick that up later on in the video. We might have a Z-axis around here. This threaded rod includes a couple of needle bearings and thrust washers. Those needle bearings and thrust washers should be lubricated weekly or quarterly, depending on the amount of use. See if you can show them this right here. This is what I'm talking about here. These are the needle bearings above and below this aluminum block, and there's our threaded rod right here. This is all located in the Z-axis assembly under the covers there. It's important that you lubricate your needle bearings with a little bit of oil, such as tool oil or 3-in-1 oil, and then on a monthly or quarterly basis, it's a good idea to clean your threaded rod. You could use a toothbrush and some degreaser like Formula 409 for this. Your threaded rod can then be lubricated with a non-petroleum based lubricant. For your threaded rod, make sure you're using something like a graphite or a silicone spray. We've come to like the silicone WD-40. Just make sure you're not using regular WD-40. You don't want to use grease. You don't want to use anything petroleum-based for this Z-axis threaded rod. You want to make sure you're using a silicone or spray graphite for that Z-axis threaded rod. All right, some of the other maintenance things that you're going to want to check out in particular are maintenance on your torch right here. When it comes to your consumable stack, it's important to take a look at the condition of your consumables. Of course, this includes your shield, your retaining cap, your nozzle, and your electrode. Additionally, here in the torch body we have our swirl ring. Swirl ring just pressure fits in there. And we've also got this torch body O-ring. Now this O-ring right here can become checked, cracked. If it does so, it's going to allow air to escape improperly. That torch body O-ring should be lubricated monthly or quarterly basis, depending on how often you're using your machine. Hypertherm does have a specific silicone lubricant for this that is going to help keep that lubricated and help keep all of your compressed air going into your plasma stream instead of exiting out the wrong direction. Putting our consumable stack here together, we've got our swirl ring. It's very difficult to see when this swirl ring is worn. It's possible that these holes could be enlarged, it's possible that they could develop cracks in between them, and it's also possible that it could slide too easily on here. It can be worn as the electrode and the swirl ring are sliding together. So Hypertherm has a manufacturer's suggested change-out period of 3 months on these little guys. So I know it's difficult to tell when it's worn, so stick to the manufacturer's recommended change-out time of every 3 months if you're using your table on a regular basis. So I like to put this swirl ring up into the torch body. Just pressure fits up in there, and then I build my stack by taking my retaining cap, threading on my shield. This is a standard shield. You want to make sure this shield is free of obstructions. You want to make sure all those little holes are clear. And you're going to thread that on without cross-threading it. If it gets too tight too fast, it's probably cross-threaded. There we go. Got that snug. Then we can drop our nozzle in. This is a standard 65, no, this is actually a 45 amp nozzle as shown on the side of the nozzle. That means I need to make sure I'm running 45 amp processes through this. As soon as I strike a 65 amp arc through a 45 amp nozzle, it's going to blow that nozzle and it's not going to react properly. So that is one of the benefits of the HYT SimKit ArcSync technology, is that it's going to set it to 45 amps based on the tool that you select in the G code. You always have to make sure you match up the tool that you're selecting in the code to the nozzle that you have installed. So I'm going to go ahead and drop my nozzle into my retaining cap and shield assembly. That's going to go in crooked. So I'm just going to shake it around until it settles out. Then I'm going to take my electrode. You can see the end with the hafnium that makes contact with the nozzle. And you can see the end with the spring that allows it to connect and then separate. I'm going to drop the hafnium end in and have the spring end up. Again, it didn't quite seat in there properly, so I'm going to shake it around until it all seats. It's all happy in there, so I'm going to thread that back up onto my torch body to make sure that I'm not messing up the spring as I'm fitting that electrode up into the swirl ring. Just fit that whole stack onto there, twist it a couple of times, make sure it's still loose, right? Still got a little bit of wiggle to it. I'm putting brass threads on brass threads here. I don't want to cross thread those. So I'm going to reinstall that retaining cap. This torch body has a pin switch right here. This pin switch tells the system that the retaining cap has been removed. So when I push that retaining cap back on, it's going to depress that pin switch. Excuse me. And of course, since we removed our retaining cap, we've got an 050 code here on our plasma cutter. So I'm going to go ahead and reach back here to my power switch, off, then on again. And we've reset our plasma cutter. Teachers, you'll probably want to teach your students to turn the plasma cutter off first, and then change your consumables out, and then turn the plasma cutter back on. That's going to be your safer route. Okay, so we've talked about basic setup. We've talked about maintaining our ArcPro CNC system. We are just about ready to go into operation. Any questions before we do so?
Tim Tucker said we are good.
Okay, great.
All right, I'm not sure what is showing up on the other side. It could be a little more static, so we could slow it down just a hair.
How do you mean?
In the live from the customer's view, it could be slowed down. Normally live videos are a little bit staticky. We could slow it down just a hair as well.
Slow down what?
The presentation.
Okay,
Mhm.
all right, gotcha.
Give some time in between. Let it all load up.
Yeah, good call. Okay, so there's a couple other maintenance points I wanted to touch on real quick. It's just some little things like our drivetrain. I wanted to point out the gear racks that we have over here. The gear racks running the length of each table and on the back of the gantry. These gear racks don't require a whole heck of a lot of maintenance. Hit them with some compressed air just to blow them off every once in a while. Maybe a rag and some WD-40 just to keep them from rusting. Otherwise, these gear racks don't require a whole heck of a lot of maintenance. They are face down, so you don't have junk collecting in the teeth. You do have your motors up under your motor covers here. You've got your bearings connecting to your rails, and then you've got your motor belts. These motor belts connect to the pinion gear and to the drive spindle that connects to your gear rack here. Tension on that will be set from the factory, but after a semester's worth of use, or I should say a school year's worth of use, it's a good idea to check your belt tension and check your bearings to make sure they're not free spinning, and make sure your belts aren't too loose. Make sure they haven't loosened up over time. Additionally, it's a good idea to clean off your ground tab, particularly if you've got your work lead bolted to your ground tab. You're going to want to unbolt that at the end of the semester and hit that with a wire brush or some Scotch-Brite to remove debris, so you're making a good connection, or I should say to remove corrosion, so you're making a good connection between your work lead and your ground tab. All right, so we've got our control cabinet mounted onto our table. We've got our wires connected. It's time to fire our system up. I'm going to go ahead and shut it down real quick so I can walk you through the process. So when it comes to shutting down the CNC system, I'm going to use the start menu in the upper left-hand corner. This button up here is your start menu. Rather than having a start menu down at the bottom like Windows, your Linux system, the start menu is up at the top and your toolbar is up at the top. This is your power down button right here. So that's going to allow us to bring up the power options, and we're going to choose shut down. Once we've chosen shut down on the desktop of the computer, that's going to be shutting down this mini computer right here. That little light will go out, and once that little light has gone out, you can then turn the rest of the system off. You can turn off your motor controller, and you can turn off your power strip right down here. Turning the system on and turning the system off are slightly different. Once you've got your system all connected and you're ready to turn it on, you're going to be turning on your power strip, turning on your computer, and then turning on your motor controller. Keep in mind, shutting the system down is not the opposite of this. You don't use that button to turn the computer off. You turn the computer off from the desktop. All right, so once we turn on our power strip, turn on our computer, and then turn on our motor controller, the desktop shows up right here. The desktop allows me to launch any of my different drafting programs. QCAD's going to be used for dimensional drafting, like car parts, brackets, things like that. Inkscape is going to be used for artwork such as pictures or company logos, text, clip art that you download online. That's all going to run through Inkscape. Both of these programs create DXF files, and those DXF files are imported into SheetCam. SheetCam is what's going to turn our drawings into cuttable files. Those cuttable files are then run through the plasma profile of Command CNC. The plasma profile of Command CNC is what I'm going to launch right now. which allows us to run G-code, move the table around, and fire the torch. As you can see here, Command CNC launches with the Command CNC window. I'm going to make this window bigger by maximizing it here, and then I'm going to take it out of E-stop right over here. It will always start out in E-stop, and so you have to take it out of E-stop before you can move the table around. In order to move the table, I'm going to jog it utilizing these arrow keys right here. I'm going to use the down arrow key to bring the torch forward. Can you get an angle where you can see the keyboard and the torch?
Mm-hmm.
You can use the left and right arrow keys to move it left and right. And you also have page up and page down to move the Z-axis. I'm going to raise my Z-axis up, and I've jogged close to the front left corner of the CNC system. At this point in Command CNC, I'm going to use the Home X and Home Y buttons. So when I hit Home X and Home Y, it's going to move the torch to the front left corner of the table. That sounded like a switch problem. I'm going to do a quick diagnosis on that. So this gives me a great opportunity to show you guys the diagnostics screen. This diagnostics button right here is going to be one of the first places that you check when you hook your system up. This diagnostics screen shows us the input status lights. You'll be able to see the switch light up here, and the switch that's acting up is this A switch right over here. Do you have that lighting up there?
Negative.
Negative. It doesn't feel right either. So it appears we're going to have to do a little troubleshooting on this system to get it to home properly. What you heard was the gantry continuing to hit up against the front stop here. When you're homing your system, what this does on the y-axis is it brings the gantry forward until it touches off the switches. Now these switches can be somewhat delicate. Oftentimes we're loading steel over the side of our CNC system. And if you're loading a piece of steel off the side here, we'll often lean the steel up against the side of the table. And if you're too close to this switch, you can end up knocking that button right off right there. So this is the switch that is currently giving us a little bit of grief. What this switch does is it tells the system when it's come forward to the front of the table. And it's very important that we home the system at the beginning of every day. When you're launching Command CNC, as we've just done, we must home the gantry to the front of the table. That tells it that it's come all the way forward. We also home the torch all the way to the left side of the table. We put it in table home. This position is as far left and as far forward as it can go. By homing the system to the front left corner and zeroing it in the front left corner, we're telling the table its parameters. We're telling it that it can't go any further to the left and it can't come any further forward to the front. That tells it the soft limits. So that way the torch cannot over travel. You can't run it into the hard stops left or right, front or rear. But if you don't home and you don't zero, it doesn't do that. So you must home and zero when you launch Command CNC. Immediately after launching Command, you make the screen bigger, you take it out of E-stop, you drive your torch over to the front left corner, then you home X and home Y. You then 0X and 0Y. From that point, you can utilize your soft stops to keep you from grinding your gears, keeps you from running into the hard stops, and you can also utilize your load material function, which is going to automatically send your gantry to the back and run the torch over to the right to make it easier to unload your scrap and load in a new sheet of steel. So, let's take a look back here. I'm going to manually jog the gantry back up to the front. simulate it as if we were homing it. Wrong button. There we go, that's the one I wanted to hit. All right, so I'm going to take it back into the live view, and I'm going to 0x, and I'm going to 0y. By homing the torch into the front left corner, it sets up our perimeter. So you can now see these are the table's limits around the sides. This allows us to utilize functions such as the load material function. So if you go from your auto button over to manual, it gives you the opportunity to load material. Load material is going to run the gantry all the way to the back and run the torch all the way to the right. All right, once we get that switch fixed, then we'll be able to utilize that function. But that function's not going to work until we can properly home and zero the system. So we've got a couple other things here to do in Command CNC. This is our main control program. Yeah, we're going to take a break here in just a minute. Alrighty, so in Command CNC, this is where we're going to load our G code into. This is going to read the code, it's going to move the motors, and tell the system what to do. So I'm going to run through the process real quick of creating a part, and that should take us right up to our first break. So I'm going to go ahead and minimize Command CNC, and I'm going to open up QCAD. I'm going to utilize QCAD to create a quick little part. Here in QCAD, you can see the grid, and this is our origin point. This is 0, 0 right down here. I'm going to zoom in on the origin point, and then I'm going to utilize my line tools. These line tools up here allow me to do a line from 2 points. I'm going to choose the origin point, 0, 0, and I'm going to pull it out to about 1.5 inches. Bring it up to 1.5 inches by 1.5 inches. Back to 0 by 1.5 inches, and back to 0, 0. So I've created a box that's 1.5 inches by 1.5 inches long. I'm going to cancel this function with a right click. I'm going to choose an arc function. I'm going to go back here to my arc tools. I'm going to choose an arc from 2 points and an angle. My angle is going to be 180 degrees. It's going to go in a a clockwise direction. So that means I'm going to start from the intersection of these lines and go to the intersection of those lines. There's my arc. Now I can put a circle into it. I'm going to put a bolt hole through it and utilize the circles tools here. I'm going to do a circle from a diameter and a center point. And I want to put a 3/8 inch bolt through here, so I'm going to oversize it just a little bit to 0.4. I'm going to put it in the center, or the middle, of that line. I'm going to cancel out of that function, go back to my regular selection arrow, and then select this line and delete it. So now I've got a little tab right here. This little pivot tab can be saved. So I'm going to save as a DXF file. You can see this is a DXF drawing. I'm going to save my pivot tab and use the Plasma User desktop. Just going to save that onto the desktop there. I'm going to minimize QCAD now, and you can see the pivot tab.dxf that I've created with QCAD. Now I'm going to take this DXF file and I'm going to import it into SheetCam. I can't drop it into SheetCam, I can't click on it. I have to open SheetCam and I have to import that into it. Once SheetCam launches, I'm going to do a file, import drawing. Here, import drawing is going to allow me to navigate to my desktop, to my pivot tab.dxf file. Make sure that this setting right down here is set to DXF files if that's what you're looking for. Opening that brings up my DXF drawing import options. I'm going to bring it in inches, bring it into the bottom left corner, and I'm going to use the drawing name as the part name. So here's my pivot tab that I drew. I'm going to quickly give it an operation by going up to operation and then choosing plasma cut. Here's my jet cutting window, which we're going to get very familiar with. We're going to dive deeper into this in the second portion of our training. I'm going to give it an outside offset on the proper layer with the proper tool. Keep in mind we have a 45 amp nozzle in there, so we want to run at 45 amps. And we've got some 1/4 inch steel on the table. So we're going to choose a 45 amp 1/4 inch steel tool. That's going to run at a feed rate of 48 inches per minute. And a lot of these settings we don't have to worry about. These are all set up properly. Everything's good to go. I'm going to give us an arc in and no lead out. Then I'm going to go ahead and click OK. We're going to go through this in a lot more detail as we continue on, but initially I'm just running you through the process so you can see how easy it is from creating a part to cutting a part. So we've created our cut path. We've given it this operation. It's an outside offset operation, run on the outside of the line and run on the inside of the hole. And we're going to use tool 9, which is a 45 amp 1/4 inch steel tool. I'm going to run the post processor to create our G-code file, saving a pivottab.ngc to the desktop. This ngc file is the type that we like to use. I'm going to click OK on that and then minimize. And here's my pivottab ngc file. So I used QCAD to create pivottab.dxf. I then imported that into SheetCam, used SheetCam to create pivottab.ngc. This .dxf file is a drawing. This ngc file is G-code. This G-code is a list of letters and numbers, essentially commands, that tell the motors where to go and tell the torch when to fire. We're going to run this ngc G-code file through the plasma profile of Command CNC. I already launched that previously. I maximized the screen, I took it out of e-stop, and ostensibly I homed and zeroed it. So I'm going to go ahead and open up my file from my desktop. There's my pivot.ngc file. Open that up, and now that is displayed on the screen there. Okay, so that was our process of creating a part and camming a part. We're going to go through that in a lot more detail, and we're actually going to cut this part when we come back. We're going to take a break at the moment. We're going to fix that switch, then we're going to come back